The National Electrical Code, or NEC, and the National Fire Protection Association, or NFPA, have restrictions on the lengths of flexible cables that can be used between sources and loads within a complex machine. The NEC in Article 400.10 states that flexible cords are not permitted for use as permanent wiring. Article 330 provides specific rules for the installation and use of flexible cables. NFPA 79 Section 12.46 states that flexible cords shall not be used for permanent wiring. Section 12.47 provides specific rules for the installation and use of flexible cables in industrial machinery. Neither the NEC nor NFPA specify a maximum length for flexible cables used in complex machines. However, the following general guidelines are recommended. Concerning the NEC, flexible cables should be used as short as possible and should not exceed 6 feet or 1.8 meters in length. As for NFPA 79, flexible cables should be of the shortest practicable length, but not more than 10 feet or 3.0 meters in length. There are some exceptions to the maximum length restrictions. Firstly, when used for specific purposes, such as connecting portable equipment to a fixed outlet. Secondly, when the length is necessary for proper operation of the equipment. And thirdly, when the cable is protected by a conduit or other approved method. In addition to length restrictions, the following factors should be considered when using flexible cables in complex machines. Firstly, mechanical protection. Flexible cables must be adequately protected from physical damage. Secondly, voltage drop. The length of the cable will affect the voltage drop, which should be within acceptable limits. Thirdly, connection method. Flexible cables must be securely connected to termination points. While the NEC and NFPA do not specify strict maximum lengths for flexible cables in complex machines, they recommend using the shortest possible lengths and following specific guidelines to ensure safety and proper operation. To elaborate, let's dive deeper into the specifics of these guidelines and considerations. Regarding the NEC, Article 400 focuses on flexible cords and cables. It's crucial to understand that these flexible wiring solutions are designed for specific applications, primarily where flexibility is essential, such as connecting portable appliances or equipment. The prohibition against using them as permanent wiring is rooted in their construction, which typically isn't as robust as that of cables intended for fixed installations. These flexible cords are more susceptible to physical damage and environmental factors, which could lead to safety hazards if used inappropriately. Article 330, on the other hand, addresses metal cloud cable, type MC. While not strictly flexible cable in the same sense as cords covered in Article 400, it does offer some flexibility and is often used in machinery and industrial settings. Article 330 outlines the permitted uses and installation requirements for Type MC cable, ensuring it's properly supported, protected from physical damage, and terminated correctly. Now turning to NFPA 79, this standard specifically addresses the electrical requirements for industrial machinery. Its focus is on ensuring the safety of both the equipment and the personnel operating or maintaining it. The restrictions on flexible cords, similar to those in the NEC, are intended to prevent their misuse in permanent wiring applications within the machinery. Section 12.47 of NFPA 79 provides detailed guidance on the proper use of flexible cables in industrial machinery. It covers aspects such as conductor sizing, insulation types, and routing methods. The standard emphasizes the importance of selecting cables that are appropriate for the specific environmental conditions and mechanical stresses they will encounter within the machine. For example, cables exposed to oil, chemicals, or extreme temperatures must be specifically rated for those conditions. Now let's address the seemingly contradictory recommendations regarding maximum lengths. The NEC suggests keeping flexible cables as short as possible and generally not exceeding 6 feet. While NFPA 79 allows for slightly longer runs, up to 10 feet, provided it's the shortest practicable length. The key here is the phrase shortest practicable length. Both standards prioritize minimizing the length of flexible cables to reduce the risk of damage, voltage drop, and other potential issues. The difference in the recommended maximum length reflects the different scopes of the two standards. The NEC covers a broader range of electrical installations, while NFPA 729 is specifically tailored to industrial machinery. In industrial settings, slightly longer flexible cable runs may be necessary to accommodate the movement of machine components or to reach remote connection points. However, even in these situations, the length should be kept to an absolute minimum. The exceptions to the maximum length restrictions are also important to understand. When flexible cables are used to connect portable equipment to a fixed outlet, such as a power tool plugged into a wall receptacle, the length may need to exceed the typical limits. Similarly, if a longer cable is essential for the proper operation of the equipment, such as a robotic arm that needs to move freely within a certain range, an exception may be granted. However, in these cases, it's crucial to ensure that the cable is adequately protected from damage and that all other safety requirements are met. Protecting the cable with a conduit or other approved method is another way to justify exceeding the maximum length restrictions. By enclosing the cable in a protective raceway, it's shielded from physical damage, environmental factors, and potential hazards. This approach can be particularly useful in industrial environments where cables are exposed to harsh conditions. Beyond the length restrictions, there are several other critical considerations when using flexible cables in complex machines. Firstly, mechanical protection is paramount. Flexible cables are inherently more vulnerable to physical damage than rigid wiring methods. Therefore, it's essential to protect them from abrasion, impact, and other potential hazards. This can be achieved through various means, such as using cable trays, conduits, or flexible sleeving. The specific protection method should be chosen based on the environment and the expected level of mechanical stress. Secondly, voltage drop is another important factor to consider. The longer the cable, the greater the voltage drop will be. Excessive voltage drop can lead to reduced performance of the equipment, overheating of the conductors, and even equipment failure. To minimize voltage drop, it's essential to select the appropriate conductor size for the length of the cable and the amount of current it will be carrying. Voltage drop calculators and NEC tables can be used to determine the correct conductor size. Thirdly, the connection method is crucial for ensuring a safe and reliable electrical connection. Flexible cables must be securely connected to termination points using appropriate connectors and fittings. The connections should be properly tightened and inspected to prevent loose connections, which can lead to arcing, overheating, and even fires. In conclusion, while the NEC and NFPA do not impose strict maximum lengths for flexible cables in complex machines, they strongly recommend using the shortest possible lengths and adhering to specific guidelines to ensure safety and proper operation. By carefully considering factors such as mechanical protection, voltage drop, and connection methods, you can minimize the risks associated with using flexible cables and ensure the reliable performance of your equipment. To add more color to this, let's think of the implications of ignoring these recommendations. Consider a scenario where a flexible cable within a complex machine is unnecessarily long, say 20 feet, far exceeding the suggested limits. Firstly, the increased length introduces a higher risk of mechanical damage. The cable is more likely to be snagged, pinched, or abraded by moving parts within the machine, potentially compromising its insulation and exposing conductors. Secondly, the excessive length contributes to a significant voltage drop. The equipment connected to the end of the cable may not receive the required voltage, leading to reduced performance, overheating, or even failure. This can result in costly downtime and repairs. Thirdly, a long, unsecured cable can create a tripping hazard for personnel working around the machine. It can also interfere with the machine's operation, potentially causing malfunctions or accidents. Furthermore, using flexible cables for permanent wiring applications, as prohibited by the NEC and NFPA, can have serious consequences. Flexible cords are not designed to withstand the same level of environmental stress and physical abuse as cables intended for fixed installations. Over time, the insulation can degrade, leading to short circuits, ground faults, and fires. In addition, using flexible cords for permanent wiring can void warranties and create liability issues in the event of an accident. To avoid these potential problems, it's essential to follow the guidelines outlined in the NEC and NFPA. This includes using the shortest practicable length of flexible cable, providing adequate mechanical protection, ensuring proper voltage drop, and using appropriate connection methods. It also means avoiding the use of flexible cords for permanent wiring applications. When selecting flexible cables for use in complex machines, it's important to consider the specific environmental conditions and mechanical stresses they will encounter. Factors such as temperature, humidity, exposure to oil or chemicals, and the degree of flexing or vibration should all be taken into account. Cables specifically rated for these conditions should be chosen to ensure long-term reliability and safety. Regular inspection and maintenance of flexible cables are also crucial. Cables should be visually inspected for signs of damage such as cuts, abrasions, or discoloration. Connections should be checked for tightness and corrosion. Any damaged or worn cable should be replaced immediately. By following these best practices, you can ensure the safe and reliable use of flexible cables in complex machines and minimize the risk of electrical hazards. Also note that local regulations and company policies may impose additional restrictions on the use of flexible cables. It's important to be aware of and comply with all applicable requirements. For instance, some jurisdictions may require the use of specific types of flexible cables or impose stricter limits on their length. Company policies may also dictate specific procedures for the installation, inspection, and maintenance of flexible cables. Compliance with these requirements is essential for ensuring the safety of personnel and the proper operation of equipment. Ultimately, the goal is to create a safe and reliable electrical system that minimizes the risk of hazards and ensures the efficient operation of complex machines. By carefully considering the guidelines and recommendations outlined in the NEC and NFPA, and by following best practices for installation, inspection, and maintenance, you can achieve this goal. Remember that electrical safety is paramount, and it's always best to err on the side of caution when dealing with electrical systems. If you have any doubts or questions, consult with a qualified electrician or electrical engineer. They can provide expert guidance and ensure that your electrical installations meet all applicable safety standards and regulations. Furthermore, to emphasize the importance of proper voltage drop considerations, let's explore a more detailed example. Imagine a scenario where a 24 volts DC motor is located 15 feet away from its power supply within a complex machine. The motor requires 5 amps to operate correctly. If a flexible cable with an insufficient conductor size is used to connect the motor to the power supply, the voltage drop along the cable could be significant. Let's say, for instance, that the voltage drop is 4 volts. This means that the motor will only receive 20 volts instead of the required 24 volts. As a result, the motor may not be able to produce its rated torque or speed. It may also overheat and eventually fail. To prevent this from happening, it's essential to select a flexible cable with a conductor size that is large enough to minimize voltage drop. Voltage drop calculators and NEC tables can be used to determine the appropriate conductor size based on the length of the cable, the amount of current it will be carrying, and the allowable voltage drop. In this example, a larger conductor size would reduce the voltage drop to an acceptable level, ensuring that the motor receives the required 24 volts and operates correctly. In addition to conductor size, the type of conductor material also affects voltage drop. Copper conductors have a lower resistance than aluminum conductors, which means they will experience less voltage drop for the same length and current. Therefore, copper conductors are often preferred for applications where voltage drop is a critical concern. Also, the insulation type of the flexible cable plays a crucial role in its performance and safety. Different insulation materials have different temperature ratings and resistance to environmental factors such as oil, chemicals, and moisture. It's important to select an insulation type that is appropriate for the specific operating conditions of the machine. For example, if the cable will be exposed to high temperatures, a high-temperature insulation material should be chosen. Similarly, if the cable will be exposed to oil or chemicals, an oil-resistant or chemical-resistant insulation material should be selected. The NEC provides detailed information on the different types of insulation materials and their applications. It's essential to consult the NEC and select an insulation type that meets the requirements of the specific installation. In addition to the factors already discussed, the routing and support of flexible cables are also important considerations. Flexible cables should be routed in a way that minimizes the risk of physical damage and interference with other components. They should be adequately supported to prevent sagging or strain on the connections. Cable trays, conduits, and other approved support methods can be used to provide proper support and protection. The NEC provides guidelines on the proper routing and support of electrical cables. It's important to follow these guidelines to ensure the safety and reliability of the electrical system. Furthermore, the termination methods used for flexible cables are critical for ensuring a safe and reliable electrical connection. The terminations must be properly installed and tightened to prevent loose connections, which can lead to arcing, overheating, and even fires. Only approved connectors and fittings should be used for terminating flexible cables. The NEC provides detailed information on the proper termination methods for different types of cables. It's essential to follow these guidelines and use qualified personnel to perform the terminations. To emphasize the importance of proper termination methods, consider a scenario where a flexible cable is improperly terminated in a junction box. The wires are not securely connected to the terminals, and some of the strands are frayed. Over time, the loose connection can cause arcing and overheating. The heat can melt the insulation in the wires, creating a short circuit. This short circuit can cause a fire in the junction box, potentially spreading to other parts of the machine or building. To prevent this from happening, it's essential to use proper termination methods and ensure that all connections are tight and secure. Regular inspection and maintenance of electrical connections can also help to identify and correct potential problems before they lead to serious hazards. In addition to the technical aspects of flexible cable installations, it's also important to consider the human factors involved. Proper training and education of personnel who work with electrical systems are essential for ensuring safety and preventing accidents. Personnel should be trained on the proper procedures for installing, inspecting, and maintaining flexible cables. They should also be aware of the potential hazards associated with electrical systems and how to avoid them. Regular safety meetings and refresher training can help to reinforce these concepts and keep personnel up to date on the latest safety practices.